All right, 7.3. Perimeter and area of plane figures. So a polygon is defined as a closed figure, and it's determined by 3 or more line segments that lie in a plane. Okay, polygons are shapes. The sides are the line segments that form the polygons. So you have your triangles, your rectangles, your squares. We have all different kinds of shapes. Regular polygons mean that all of the sides and all of the angles are exactly the same. Okay, so these are your nice pretty ones. So these are the names. These are not regular polygons. These are just the names of the plain old polygons. So if it has 3 sides, it's called a triangle. If it's called 4 sides, it's called a quadrilateral. 5 sides, pentagon. 6 sides, hexagon. 7, heptagon. 8, octagon. 9, nonagon. 10, decagon. And then there are names after that many sides, but you don't need to know them. Regular polygons for 3 and 4 sided figures have special names. Okay, and we'll talk about those names shortly. 5 or more sides, they do not give special names to regular polygons. Okay, the most common special regular polygon that you guys have heard of is a quadrilateral is a square. Okay, 4 sides are the same. 4 sides, 4 angles. That's the most common one. But we'll talk about all the special names here in just a minute. There's lots of definitions for 7.3. Okay, so we start with triangles. So all of these are triangles. The first one is an acute triangle. An acute triangle has 3 acute angles. Remember, acute means that it's between 0 and 90 degrees. An obtuse triangle means it has 1 obtuse angle. If you remember from before, a triangle can only have 180 degrees. An obtuse angle is between 90 and 180, so it's not even possible for a triangle to have more than 1 obtuse angle. Okay? A right triangle has 1 right angle. Same thing with a right angle. It's not possible for a triangle to have more than 1 right angle. You can have 1 90-degree angle. Once you have 2, there's not enough. You have to have 3 angles in a triangle, and there can only be 180 degrees. Isosceles triangle. An isosceles triangle has 2 equal sides and 2 equal angles. And when you guys took geometry, you learned theorems that if there's 2 sides that are the same, there has to be 2 angles that are the same. You can't have one without the other. An equilateral triangle has 3 equal sides and 3 equal angles. These are often also called equiangular. And then we have a scalene triangle, which has no 2 sides the same. There's no sides, no angles, nothing is the same. All 3 sides, all 3 angles are all different. Then we get into our quadrilaterals. There is a fabulous flow chart on page 378. And I'll show you that here. I guess I should have had my book ready. All right, here we go. I did not want to redraw this because you guys have your books and you can refer to this. Okay, so quadrilateral again just means it has 4 sides, 4-sided polygon. Okay, these break into 2 different parts. We have the trapezoids. Trapezoids are defined as having 2 sides parallel. And then you can have a special trapezoid called an isosceles trapezoid, where these 2 sides are congruent. Okay. The other special ones start with a parallelogram. So if you have 4 sides, if both sets of opposite sides are parallel, it can be called a parallelogram. It also happens that the opposite sides are congruent. These 2 are the same and these 2 are the same. Opposite angles are congruent. These 2 angles are the same and these 2 angles are the same. Parallelograms break off into 2. You have a rectangle. So we still have opposite sides parallel. We still have opposite sides equal in length. All angles are 90 degrees. Diagonals are also equal in a rectangle. Okay, and I'm going to keep going because if you have a rectangle, and all of the sides are the same, then it becomes a square. We still have opposite sides parallel. We still have opposite sides equal. We still have all angles measured 90 degrees, and then diagonals are equal. But instead of just opposite sides, all of the sides are the same. So that's the one difference between a rectangle and a square. A rhombus is like a parallelogram where you have opposite sides congruent, but then you have 4 congruent sides, okay? And there are often, in a lot of flowcharts, there's another line drawn from here to here, because if you have a rhombus and all of the sides are the same in your rhombus, then it becomes a square. So there's lots of different ways to make these flowcharts, but often in your book does not do this, but a rhombus can become a square if all 4 angles are 90 degrees. Okay? So we're going to go back to my written out notes here. Okay, again, that quadrilateral flowchart is on page 378. Then we get into the definition of perimeter. Okay? Perimeter is the distance around the outside of a figure. So we have a rectangle. Opposite sides are congruent. We have 4 90-degree angles. I labeled my sides length and width, so I'd had W plus L plus W plus L. So to simplify that, the perimeter is equal to 2 lengths plus 2 widths. Whether you use this formula or whether you add the 4 sides together, it does not matter. You're going to get the same answer. Perimeter of a triangle. I chose a scalene triangle where none of the sides are the same. It doesn't matter if any of the sides are the same or not. To find the perimeter of a triangle, you just add them all together. Okay? Square. In a square, all 4 sides are the same. So to find the perimeter of a square, instead of adding S plus S plus S plus S, I can just take 4 times S. And then parallelogram, the side, and then these are often called the base. You just, again, add all 4 of them up, but I have 2 sides, 2 bases, so the perimeter is 2 bases plus 2 sides. And these are all in your book too, if you're not writing them down right now. All right, so example 1 is on page 379, and it says you want to trim a rectangular frame. You want to trim a rectangular frame with a metal strip. The frame measures 30 inches by 20 inches. Find the length of the metal strip you will need to trim the frame. So all you're doing is finding the perimeter of the rectangle. So the perimeter of the rectangle is 2 lengths plus 2 widths. And whether you can do this in your head or you use a calculator, I don't have to, I wrote parentheses to show multiplication, but I can just do 2 times 30 plus 2 times 20. And I get 100. And these are in inches, so my perimeter is in inches, because perimeter is, again, measuring length. Check your progress. 1 is on page 380. Find the length of a decorative molding needed to edge the top of the walls in a rectangular room that is 12 feet long and 8 foot wide. So 12 feet long and 8 foot wide. Again, we're just looking for the perimeter. So I take 2 of my lengths plus 2 of my widths. So I do 2 times 12 plus 2 times 8, and I get 40 feet. Example 2, it's on page 380. Find the length of fencing needed to surround a square corral that measures 60 feet on each side. So I can take 60 times 60 plus 60 plus 60 plus 60, or I can just take 4 times 60 and get 240 feet of fencing. Check your progress 2. A homeowner plans to fence in the area around the swimming pool in the backyard. The area to be fenced in is a square measuring 24 feet on a side. How many feet of fencing should the homeowner purchase? So again, fencing, we are doing perimeter, the distance around. So I take 4 times 24 and I get 96 feet.